Hey, welcome back. So let's just dive right in. There's this huge, almost invisible revolution happening all around us. And no, it's not in our phones, it's not even in our cars. It's in the massive network that powers all of it, our electrical grid. We are talking about a total rethink of how energy moves, and it's all being driven by artificial intelligence. And this whole thing really kicks off with a question that's becoming more important every single day. As we all start plugging in our electric cars, we've got to ask, is the grid that was designed like 100 years ago actually ready for this? Because here's the thing, the problem isn't just about using more electricity. It's about the chaotic, unpredictable nature of that demand. Think about it. When everyone on your block gets home from work and plugs in their EV at the exact same time, it can create these sudden, massive power spikes that our old, steady-state grid just wasn't built for.
So this brings us right to the heart of the matter. Our grid is facing an overload problem. But it's not just about energy. It's about complexity. This slide really lays it out perfectly. For a century, the grid was basically a one-way street. You had a big power plant, power flowed down the lines, and it ended up at your house. Super simple. But the future? That needs to be a two-way superhighway with energy and information flowing in both directions, from our solar panels, out of our EV batteries, from all of our smart appliances.
And that two-way highway? Well, that's the fundamental idea behind the first part of the solution, the smart grid. So what is a smart grid? Simply put, it's a power network that can talk and listen. It uses digital tech, like the smart meter in your home, to get a real-time picture of exactly what's happening, and then react instantly to all the little shifts in supply and demand. But when you have millions of new devices all talking at once, that creates a brand new problem. Every single smart meter, every EV charger, every solar panel, they're all generating data every single second. This isn't just a stream of data, it's an absolute tidal wave. And trying to manage that tidal wave with the tools we have now, well, that just creates a huge new bottleneck in the system. Now, normally you'd think, okay, just send all that data to a big centralized cloud to figure it out, right? But that approach has some serious flaws. First, latency. The time it takes for data to travel there and back is just too slow for a grid that needs to react in milliseconds. The bandwidth costs would be astronomical. And, maybe most critically, it means sending super sensitive data about your personal energy use across the open internet. That's a huge privacy risk. And this is where things get really clever. This is the next evolution of the solution. Instead of sending all that data to one central brain, what if we could bring the intelligence out to the very edges of the network? This whole concept is called edge computing. It's all about putting the processing power, the AI, right where the data is being created. So don't think of it as one giant supercomputer far away in the cloud. Instead, picture it as thousands of tiny, super-fast brains embedded directly into meters, transformers, and charging stations all across the grid. So what can these tiny brains actually do? Well, they're already being put to work solving three really critical problems: managing that chaotic EV charging demand we talked about, spotting energy theft, and maybe the most important one of all, defending our grid against some pretty sophisticated cyber attacks. Let's start with energy theft, because this number is just wow. In some parts of India, over a fifth, more than 20%, of all electricity is just lost to theft. AI at the edge can fix this by learning the unique energy patterns of a specific neighborhood. It can spot any weird anomalies that signal fraud, and it can do it in real time, right at the source, without ever needing to see your personal, private data. But there is an even bigger threat out there. The very same smart meters that make our grid intelligent can also become a target for hackers. They can use something called a false data injection attack to feed the system bogus information, basically lying to the grid to trick it into thinking there's a problem or to hide a real one. An attack like that could destabilize the entire system. So how in the world you fight a data-driven attack without compromising everyone's privacy? The answer is this absolutely brilliant AI technique called federated learning. It's a way to get the benefit of everyone's data without anyone ever having to actually share it. Okay, so here's how it works. Step 1. A little local AI model is trained right on your device. Let's say your smart meter at home. It learns what normal and abnormal energy use looks like for you, but that raw personal data, it never ever leaves the meter. Then, for step 2, and this is the magic part, the meter doesn't send your data anywhere. It only sends the anonymous learnings, basically the mathematical patterns it discovered. Those anonymous learnings get sent to a central server where they're combined with learnings from thousands of other meters to build one incredibly powerful global model that understands the health of the whole system. And does it actually work? Oh yeah, a recent study testing this exact method found it could detect those sophisticated cyber attacks with an average accuracy of 88%. That's a massive leap forward for grid security, and it's all done while keeping your personal data completely private. Okay, so we've been talking about a lot of high-level tech here. Let's bring this all back home. What does any of this actually mean for you in your day-to-day life? This right here gives you the big picture. From the power plant all the way to your smart home, the entire ecosystem is becoming this intelligent, communicating network. It's a hybrid system, right? Some of the big picture analysis happens in the cloud, but the critical split-second decisions are made instantly, right at the edge. At the end of the day, what this means for you is pretty simple. An AI-powered grid means greater reliability, fewer blackouts. It means a grid that is way more secure against cyber attacks. And honestly, it's the only way we can seamlessly integrate renewables and all the new demand from EVs to build a truly sustainable future. And it's not just us saying this. As Sancheth Bhatt, a former utility executive, puts it, the old way of doing things just isn't going to cut it anymore. This isn't about small tweaks. It's a complete paradigm shift. It requires a totally different approach. And that really leaves us with one last big question. The technology we've talked about today, the AI, the edge computing, the federated learning, it's here, it's real, it works. But transforming a system that's been in place for 100 years is a monumental task. So the real question now is, are our utilities and regulators actually ready to make it happen?